Hey guys, Mr. King here. Today we're going to talk about the atmosphere. It's the air up there. It's the air that surrounds planet Earth. And our atmosphere allows us to live here. We have the only atmosphere on the planet which allows for plants and animals and humans to live. And our atmosphere is divided into a couple different layers, and each layer kind of has a different job of making the Earth a safe place to be. So today we're going to talk about those layers, and we're going to talk about what they're made up of. So our atmosphere is a layer of gases. There's many gases in the atmosphere. It's made up of a combination of a lot of different things. A lot of people believe that our atmosphere is made up of oxygen. And there is some oxygen in the atmosphere, but it's not the most common. Nitrogen is actually the most common gas in the atmosphere, and nitrogen is used by a lot of really small organisms like bacteria to create different processes to allow them to live, which is very important for our food chain and our food webs to allow larger organisms to live. And so they use nitrogen in lots of processes to help them survive. And so that's really common in our atmosphere, and it gets used up. You can see oxygen makes up 21% of the atmosphere, so those two, nitrogen and oxygen, make up 99% of the atmosphere. So that's mainly what it is. But then we also have some water vapor in the atmosphere, and that gives us clouds and precipitation, and you guys know water vapor is just water that has evaporated, whether it be from the heat or from the sun. It rises up and enters the atmosphere. And then we also have carbon dioxide in the atmosphere as another one of the gases that allows us to keep warm. Okay, it kind of acts as a blanket that traps the sun's heat after it enters our atmosphere. It kind of keeps it close to the earth and allows it from escaping out into outer space. And carbon dioxide is also used by plants to make food. You guys know when we exhale, we release carbon dioxide. Plants are kind of the opposite. The plants like to take in that carbon dioxide and they release oxygen for us. So we kind of have opposite jobs there. Without the carbon dioxide, plants wouldn't be able to go through the process of photosynthesis, producing their own food, and that would cause us to have a lack of plants to eat, but also a lack of oxygen. So each one of these gases is really important in providing us with a stable atmosphere where we can live. If you take any one of these gases out, it's going to cause a problem. Aerosols are things that are in our atmosphere, but they're not gases. They're solids in the atmosphere. And at any time, you can have some aerosols floating around in the atmosphere. Some examples, dust, salt, pollen, tiny acid droplets. There might be some dirt flying through the air if we have a tornado or something like that. But it's not just gases in the atmosphere. There's also some solids that are floating through there, and those all move from place to place within the atmosphere. So here's our layers. You can see in the green area there it says the Earth, and we've basically got divided into 5 layers. You got the troposphere, which is where we live. It says that's where life forms, that's where living things are going to be. Also the weather all occurs in the troposphere, where you get your rain and most of your clouds and your tornadoes and hurricanes and things like that. And that accounts for 75% of the atmosphere, so that's where most of the stuff is. Stratosphere is a little bit farther out. That's where the ozone layer is. If you guys have heard of the ozone before, it's going to help protect us from some UV rays. And then you go to the mesosphere. It gets a little colder. There's only a few molecules there, so there's not a whole lot of air out there, and there's very little in that area. And the thermosphere, a little farther out, fewer molecules. Large temperature fluctuations, because now we're getting far enough away from Earth that we don't have enough heat, but we're also getting far enough away from Earth that we're getting closer to the sun. And then the exosphere, that's like when you think of outer space. That's like to outer space, or to, as Buzz Lightyear would say, to infinity and beyond. So that's kind of out in the middle of nowhere. So let's talk about the first one. The troposphere is our first layer, and this is where we live. We live in the troposphere, and it's from the Earth's surface to about 10 kilometers. Contains most of the clouds and weather. If you guys have ever been flying in an airplane, you know you can get up above the clouds in an airplane and you can get out of the weather. So if you're flying and it's a rainy day out, your pilot will drive you up above the clouds, and it'll actually be a sunny day above the clouds because you get up above the clouds and the weather. Most of the heat in the troposphere comes from the Earth. So the sun shines on the Earth, and as we've learned about, we have this process called conduction. The sun shines on some particles on the ground, and those particles start to bump each other and bump each other, and they bump each other, and they increase their kinetic energy, and then they release heat because they're moving. Remember, that's what heat is. You get it from kinetic energy, from things moving. They release heat, and that comes from the ground and rises up. So right next to the ground is going to be our warmest area. As you go up, temperature cools about 6.5 degrees Celsius per kilometer of altitude. So as you go up in the air, it actually gets quite a bit colder. If you were to go hiking on Mount Everest, which is the tallest mountain in the world, it's about 9,000 meters tall. And so that equates to about 9 kilometers. So if you started at the bottom, let's say it's an average day there, it could be 45 degrees down at the bottom. By the time you climb to the top, it could be negative 50 degrees. There's that much of a change. It could change almost 100 degrees Fahrenheit, which is our scale we're used to. So from the bottom to the top of the mountain, just climbing that 9,000 meters up, it'd be a huge swing in temperature, and that's because the higher you get, the farther you are away from the Earth's surface, which is letting all the heat off. So if you're down close to the ground, we feel a lot of that heat where we are. But if you go up in the air, if you guys have ever climbed a mountain or been up in the air of any sort, if you even hike up a hill that's a large hill, you can feel the temperature drop a little bit. And it's because you're not getting all that heat from the conduction of the Earth down on the ground. So that's our layer we live in, troposphere, and this is probably the most common one that you guys are going to know about because it's where we live, it's where the heat is, it's where we have clouds and weather. It's kind of where everything occurs. If you go up above that, you get the stratosphere, from 10 kilometers to 50 kilometers above the Earth's surface. This contains the ozone layer, and this is really important because our ozone layer filters out the ultraviolet radiation from the sun. So the sun's super hot, and as it shines down on us, there is some bad radiation in the sun. If you're exposed directly to it, it can cause bad things. It could burn your skin or give you forms of cancer and things like that. So what our ozone layer does in the stratosphere is it blocks those out. There's a combination of gases in the stratosphere that allows it to block out the harmful radiation, and it allows the good radiation or the heat to still pass through. Now, a lot of talk has been made about our ozone layer being destroyed. And when we have pollution and gases that are burning up and going up into the air, part of our ozone layer is being destroyed. And where you destroy the ozone layer, you start to get holes and you start to get patches where the sunlight can shine directly through. Now, it's not like there's going to be a little spot where the sun's coming through and if anyone walks through it, they're going to get zapped and melted or anything like that. But it does allow for more harmful rays to come through, and that can lead to problems. And so as long as we try to take care of the environment and don't pollute and don't have a bunch of burning gases up in the atmosphere, our ozone layer is going to hold strong and it's going to block those rays. If we continue to pollute and we continue to have cars that have exhaust that cause a bunch of problems for our atmosphere, in many years there will be some problems with the stratosphere. It won't be as strong as it used to be, and it's going to allow different rays to come through. So here's the idea of the stratosphere. The stratosphere is that second layer from the Earth, and you can see the sun shining down, and the stratosphere is going to allow a small amount of rays to come all the way through. It's also thick enough, when you think about the gases that it's made of, the gases actually reflect some of the sun's light back out into outer space. So it allows an appropriate amount of ultraviolet rays to come through, which blocking at the same time not too many. So it's a real science, it's a real balance in order to make it work. And that's why the Earth is the only place where we can live, because our atmosphere is perfect for this. It's able to regulate things just the way we need it. If you get up above the stratosphere, you get up into the upper layers of the atmosphere. Now we're talking about the mesosphere. And the mesosphere is the next layer. It's 50 to 85 kilometers above the Earth's surface, and it's our coldest layer with little ozone. Now it's the coldest layer, which is kind of weird because you think about it's in the middle, but the reason why it's coldest is it's in the middle. It's not close to the Earth, and it's not close to the sun. The layers that are close to the Earth, like your troposphere and your stratosphere, they still get some of the heat from the Earth. If you get the outer layers, like the thermosphere and the exosphere, they get heat from the sun because they're close to that. Mesosphere is kind of in the middle, so that's what makes it the coldest layer. Thermosphere, that's 85 kilometers to 500 kilometers above the Earth's surface. It gets warm because it's closer to the sun. We're moving closer to the sun now with these layers. It filters out X-rays and gamma rays, which are also very, very harmful rays. And then the exosphere, this is the infinity and beyond, the space. This is from 500 kilometers and beyond. Contains few atoms and extends into space without a clear boundary. So this is kind of when you think of outer space, you're thinking of the exosphere. And that would be a warmer area because, once again, it's closer to the sun. So if you take a look at the temperature change as you go up through it, you can see down in the troposphere, the temperature is the highest right next to the ground. That's a Celsius scale down there on the bottom. And you can see from 0 to 10 kilometers, which is our troposphere, you can see the temperature drops. Okay, it goes back to the left, which is indicating the temperature is getting colder. It looks like it goes from about maybe 30 degrees Celsius to about negative 50 or negative 60 degrees Celsius. And that's like I talked about with Mount Everest. If you climb a 9-kilometer mountain, you're going to see a huge change in difference. Then as you go up, the stratosphere stays pretty normal. Kind of doesn't really vary a whole lot, and it's still getting some of the heat from the Earth. That's what keeps it between the 10 and the 20. As the warm air rises, that's going to keep that in the right area. And then the mesosphere, you can see it kind of dives down. It goes from 0 to about negative 100 degrees Celsius, and that gets real cold. And then you enter the thermosphere, and as you go up, you can see that temperature just spike up. And that's because you're out near the sun. You're getting to a place where the sun's rays are coming directly, and it heats up that area pretty well. So you can see there's a lot of different things going on here within the atmosphere, and there's lots of different parts, and everything's got to do its job. Otherwise, we don't have this nice balance where we get these regulated temperatures, and everything is sustainable for human life or for plant life even. So hope you guys get this. We'll talk a little bit more about it tomorrow in class. I will see you then. Make sure you do the quiz on the back. Write some good challenge questions. There's lots of fun stuff to think about when you think about what could happen. Like if you got on a rocket ship and you traveled here, what would it look like outside? Or if there was a planet that existed only in this layer of the atmosphere. Some real good thinking questions there that could be some fun discussions. So write a good one. I will see you guys tomorrow.